Hi all, welcome to Physics Login. Today we are going to start grade 12th Physics, chapter number 1, Electric Charges and Fields. In grade 12, the syllabus is divided into three parts. First part is electromagnetism, second is optics, and third is modern physics. Okay, in electromagnetism, two divisions are there. One is electrostatics and the second is electrodynamics. Okay, what is electrostatics? Electro means charge, right? Static means stationary. The study of charge at rest, the behavior and the interaction properties of charge when the charge is at rest. You will study all those things under electrostatics. In electrodynamics, as the name suggests, it is the study of moving charge. Moving charge possess certain properties. The properties of moving charges are different than that of static charge. So these two are two different branches. We have to study these two electro parts like electrostatics and electrodynamics. In electrostatics, we will study first charges to fields, three potential, and fourth one is capacitance. In electrodynamics, we know this is the study of moving charge. When charge moves, what happens? We can say current is flowing, right? So like that, in electrodynamics, you will study current, electricity, magnetism, alternating current, electromagnetic induction, EM waves, etc. All these chapters we have to study. Okay, this charges and fields is your first chapter. Okay, the electric charges and fields. We are going to start with this chapter, and potential and capacitance is your next chapter. Okay, we are going to start with the charges and electric field. So, what is charge? First, we should understand what is the definition of charge. If you can understand the concept of charge, the whole chapter, whole electromagnetism will be very easy. So first, charge. How can we define charge? What is charge? Charge is actually the basic physical property of a matter is charge. In simple words, a basic physical property of a matter, which is carried by elementary particles of matter. Okay, carried by elementary particles of matter. Those particles can exert force on similar particle. This is the proper definition of charge. I'll write it. Charge, the basic physical property of matter carried by elementary particles which can exert a force on similar particles. So this is the definition of charge. Okay, the basic property, the basic physical property of matter carried by some elementary particles in the matter, and those particles can exert force on similar particle. Okay, a matter consists of atoms, you know that, right? Atoms. What are the elementary particles in atom? Yes, electrons, protons, neutrons are the elementary particles. You know the structure of atom, right? Atom consists of at the center nucleus and electrons are revolving around the nucleus, right? What are present in nucleus? Nucleus consists of proton and neutron. So, proton and neutron, right? And this nucleus is at the center and electrons are revolving around it, right? Like this. First orbit, second orbit, it is revolving around the nucleus. Nucleus consists of protons and neutrons. If 1, 2, 3, 4, 4 electrons are there, then there should be 4 protons. Because these are those elementary particles which carries this basic physical property. What is that? Charge. Charge carried by protons and electrons. Read this statement one more time. The basic physical property of a matter carried by elementary particles, right? These are those elementary particles. What is that? Electrons and protons. Neutrons are neutral nature. They don't have any charge. So atom, the net charge of an atom, net charge is 0. That is equal number of electrons and equal number of protons. Protons are positively charged. Electrons are negatively charged. Both having the same magnitude and opposite sign. Conventionally, we consider electron as negative charge and proton as positive charge. Clear? The definition is clear to you now, right? The basic physical property of matter carried by elementary particles, that is electrons and protons. Okay, electrons and protons, which can exert a force on similar particle. These electrons and protons can exert force, right, on similar particle, other electrons and protons. This is the complete definition of charge. Clear? So as I told you, these are the elementary particles. This possesses a charge, right? That charge, electron possesses a charge and proton also. Okay, this charge is equal to electron and the magnitude is same. That is 1.6 into 10 raised to minus 19 coulomb. This is the magnitude of the charge. Charge carried by elementary particles. That is electrons and proton. Magnitude is same, but proton we denote it is positive charge. 1.6 into 10 raised to minus 19 coulomb. Coulomb, I will explain this. This is the unit of charge. Okay, as a unit of charge. This electron is negative charge. So we represent like this. If plus E is written, this is the magnitude, and minus E is written, this is the magnitude, and understand that this is electron. Minus charge is electron and positive charge is proton. Conventionally, we have taken that. It shows the product. It follows the rule of mathematical addition. When they add together, it will become 0. Plus and minus become 0. That is why the net charge of an atom is 0. Look at this number of electrons 1, 2, 3, 4. Correct? So we can say 4 negative, right? Because it is electron. Plus when you add this 1, 2, 3, 4, 4 proton plus 4 it becomes 0. So the net charge of an atom becomes 0. That is, atoms are neutral in nature. Or matters. Look at this. This matter consists of equal number of protons and equal number of electrons. That is why we can hold it easily. No charge in this. Okay. If you want to charge this, there are many ways to charge an object that we will study later. Okay. Then, when we look into this value, I will show you one thing. What is this? This is coulomb. Coulomb is SI unit of charge. SI unit of charge is coulomb, denoted by C. Okay. Okay. So unit of charge is coulomb and magnitude of charge 1.6 into 10 raised to minus 19. If it is electron, it is minus. If it is proton, it is plus. Magnitude are same for both. Okay. So, charge of an electron is equal to 1.6 into 10 raised to minus 19 coulomb. This is minus, right? Charge of an electron is equal to minus 1.6 into 10 raised to minus 19 coulomb. So we'll examine this the coulomb SI unit, okay? So you have studied in 10th grade that current is equal to charge by time, right? Charge is denoted with the letter Q. Q by T. Remember that equation? This we will study in current electricity. Now you remember this equation, right? Charge per unit time is current. Charge flowing per time is current. So from this equation, you can write Q is equal to I into T. Correct? I multiplied current multiplied by time is charge. Look at this. What is this SI unit of current? Ampere, right? Denoted by A. What is SI unit of time? Ampere second is coulomb. See, ampere second. From this equation, we can define coulomb. What is coulomb is? So look at this. If 1 ampere current passing through a conductor for 1 second, the amount, the quantity of charge is 1 coulomb. From this equation, okay? 1 ampere current for 1 second, okay? When you substitute this value, Q is equal to 1 into 1 ampere into 1 second, that is equal to 1 ampere second, that is equal to 1 coulomb, correct? 1 coulomb. Okay? So, the 1 ampere current, if 1 ampere current is passing through a conductor for 1 minute, the number of electrons passing are N is equal to 6.24 into 10 raised to 80 electrons. This is that quantity Q. This Q is equal to 6.24 into 10 raised to 18 electrons. That is 1 coulomb. Look at this. 6.24 into 10 raised to 18 into E, charge of 1 electron, equals 1 coulomb, right? From this thing you can find the charge of 1 electron. E is equal to 1 by 6.24 into 10 raised to 8, correct? 18. Sorry, 18. Okay? Coulomb. So E is equal to, when you multiply 1 by 6.24 is equal to 0.160. 160 into, when this 10 raised to 18 comes on this numerator, it will be 10 raised to minus 80, right? And this you can write as E is equal to 1.6 into 10 raised to minus 18, 90 coulomb. So this is the charge of 1 electron. Okay? Note this. You can make note of this. This is how we calculate charge of 1 electron. That we know that the structure of atom nucleus, electrons are revolving around it, right? Electrons are revolving around it. Proton, proton, E, proton, proton. Look at this. Number of electrons and protons are same. So it is neutral in nature. So by any means, okay, by any means, if you are able to add 1 electron here. Look at this, add 1 electrons by any method, okay, method I will teach you later. By any method, if you are able to add 1 electron here, what happens? The balance of the atom changes, right? Now look at this, 4 proton, that is plus. We can write it as plus 4E. Then 1, 2, 3, 4, 5 plus minus 5E. Correct? Minus 5 electron. The net charge will become minus E. Correct? Plus 4 minus 5 minus E. So we can say now it is negatively charged, right? Negatively charged. This atom is negatively charged because excess of electron is there. So in other hand, if you are able to remove 2 electrons from here, right? 2 electrons from here, from this atom. By any means, you are removing 2 electrons. What is the net charge now? Plus 4E. Protons are still in this 4P. Then plus this I remove, this I remove. Okay. Total left is 1, 2, 3. Minus 3 electrons. Correct? What is the resultant? So we can say plus E. 1 Proton is excess, so this is a positively charged atom. So the charge on a body is the net charge. Net, not the total content of charge. It contains, look at this 1, 2, 3, 4. 4 plus 3, 7, right? 7 charged particles are there. But what is the net charge? It is only 1. So charge of a body depends only on we describe only on considering net charge. Charge only we are considering the net charge. If the net charge is 0, what is the charge of the body? It is a neutral body. If net charge is negative, in negative answer we can say that body is negatively charged. If the net charge is positive, we can say that the body is positively charged. So it depends on the charge, removal and addition of electrons only, right? Why? Because this proton is bound to the nucleus, right? It is not easy to remove this. Okay? Detach this proton from the nucleus is required high energy, high force is required. And here, the outermost shell electron is easy to remove, right? Other reason is also there. Mass of, not this values, okay? Mass of proton 1.64 into 10 raised to minus 27 kg. Mass of electron is equal to 9.1 into 10 raised to minus 31 kg. It is approximately 1840 times heavier. The protons are 1840 times heavier than electron. So it is easy to transfer electron from atom. So that is the reason the charge of a body, the net charge of a body is determined by the amount of excess electron or deficiency of electron. Clear? And this process, giving charge to a body, is called electrification. Next topic is charging of a body. Charging of a body means we are giving a net charge to a body is called charging of a body or electrification. You know that when you rub a scale on your hair and it can attract small tiny pieces of papers, right? Because of there is a charge accumulation when you rub on anything. If you are rubbing scale on a woolen cloth, there is a transfer of electron occurs between those material. So one get positively charged. Which one get positively charged? The one loses electron will get positively charged. One gains electron will get negatively charged. So those accumulation of charge, those unbalanced charge, accumulation of charge can attract objects. Okay? So charging can be done in basically 3 ways. First one is charging by friction. Okay? Example is when you rub your scale on your hair, we can charge it. That is accumulation. A net charge is produced on that material. Correct? So you know that the electrons, this is nucleus and electrons is revolving around it, right? So suppose this is one material. Okay. Another material of nucleus this. So electron is here, right? These two materials, when two materials in contact, this can come like this. This atoms can come like this, right? If it is closing each other, there is no problem. If you try to rub, what happens? This bond can break this electron from this outer shell, right? The rubbing produces energy, right? Heat energy. Due to that heat energy, these electrons will be taken from the outer shell. So what happens? If the lesser bonding energy having atoms will lose energy, that means lose electron. Those electrons will get accumulated on that object. And you rub the scale, you are transferring electrons actually. Electrons and it is accumulated there. Sometimes this electron may be transferred from this object to the other object, and this will get positively charged, right? Then also there is a net charge is developed here. Net charge is not zero, then it can attract other objects. That was our definition, right? So, the method of rubbing, if you rub one material over another, we can create accumulation of net charge on the surface. That method is called electrification or charging by, yes, friction. Frictional electricity, static electricity, we can say like that, okay? Then, next is charging by conduction. Charging by conduction. If you want to charge a body, this is a body. It contains plus, minus, plus, minus, plus, minus, plus, minus. Okay. So, is there any charge in this body? Your answer will be yes, because these are the charged particles, right? Elementary particles possessing charge. But if I ask you, is there any net charge? Net charge is zero. So, net charge, if the number of electrons and protons, the positive and negative charges are equal, we can say it is a neutral body, or net charge is equal to zero. So, if you want to charge this body by conduction, what you have to do is, you have to bring a charged body. If you want to make this body a negatively charged object, what you have to do is, you bring a negatively charged, most of the charges are negative here. So negatively charged body, and make it contact with this object. Then what happens? This negative charge will transfer to the body which is to be charged. How it is charging? Because there is repulsion in this, right? Same charges repel each other. Opposite charges attract each other. Like this here, more negative charge, it always trying to repel each other. Then why this is not going out? Because this air is an insulator, okay? If they get any chance to escape from this body, it will do. So what you do, you make it contact with this object. What happened? Look at this. This excess charge, negative charge will repel and it will pass to this one, this body. It is transferred to this body, and you remove this body, charging body. This object is now, what is the net charge? Look at this 1, 2, 3, 4, protons only 1, 2, 3, 4, 5, 6, excess of negative charges there, right? So we can say this is negatively charged body. So this is the process, okay? This is the method of charging by conduction. There should be direct contact between the object which is to be charged and the charging body. There should be direct contact. If there is contact, we can say it is charging by conduction. Okay, next is charging by induction. I will demonstrate that process. Actually, if this is a negative charge, this green color is negative charge and this black color is positive charge, okay? Inside the material, what is negative and positive charge is? To the right side, inside that atom, look at this, plus and minus, equal number of plus, equal number of minus, right? This is a neutral body. Okay, what happens is, when you bring a negative or positive, whatever it may be, now I explain with the negative, highly negatively charged body, near this object, what happens? This negative charge will repel negative, right? Look at this negative charge is repelled. Similarly, all negative charges repelled here, right? And positive charge won't move. Positive charge will be there in its position. You know that positive charges are where? It is inside the nucleus. So electrons are forcing to move to one direction. Look at this. Here, from here, electron is moved to this, and at this surface. So in one surface, it is positive charge. Other side, it is negative charge. We can say it is polarized state. Okay, when this negative charge is coming closer to it, this negative charge will repel, and this situation changes to this situation. Both sides, one side positive charge is positive and negative have an attraction also. So this negative positive charge will be on this side and negative charge will accumulate on that side. And this process is called induction. Without touching, we can polarize a material, right? Polarize means one side positive, other side negative. Okay, two different charges at different sides. If you have two different opinions, we can say it is polarized opinion, right? Like that. Here it is positive and negative. Without touching the material, we can shift the negative or we can attract a positive charge. If a positive, highly positive charge comes, what happens? This will come to this side, right? This negative charge will come to this side and other side will become positive. Both is possible. Okay? Then what? This is called and this is called a polarization. Polarization of material. And when this gets polarized, we can do one thing, right? If we connect this to Earth, what happened? Earth is an ocean of electron, right? Earth is an ocean of electron. Now, Earth can accommodate a number of electrons and it can supply a number of electrons. Correct? So what happens? This thing will be go to the Earth and the object will be positively charged. Okay, when you connect this to Earth, what happens? The excess electron will get a passage to go through it because negative is repelling, right? When you get the short circuit, it will get passed to Earth. So the number of negative charge will be lesser in this object, so it is getting positively charged. Okay? If you bring a positive charge here, the opposite thing will happen, right? This negative will move to this side, other side positive will be there. And positive side will connect to the Earth. Earth is an ocean of electrons. It can supply a number of electrons. That positive charge will attract negative charge and more negative charge will come inside. Thereby, it will get negatively charged. Okay? Clear? Any confusion in charging by induction? Okay, next topic is conservation of charge. Conservation of charge is similar to conservation of energy. Energy cannot be created nor be destroyed, right? It can transfer from one form to another. Okay? Like that. Charge also, same definition. Conservation of charge is a charge cannot be created or be destroyed. It can transfer from one material to another. Okay? Or in simple words, the net charge on an isolated system, closed system, the net charge on an isolated system is constant. Net charge on an isolated system is constant. Okay, so net charge on an isolated system is constant. Suppose this is an isolated system. Okay, this isolated system, closed system, contains three spheres, charged spheres. Okay, -2, 5, 3 coulomb. Okay, -2, 5, 3 coulomb. Then then you are shaking this isolated container and the charge will get exchanged, right? Then it contains 2, 3 and what will be this x? What will be this x value? How can you calculate it? We know that the net charge on an isolated system is constant. So net charge on this system, what is this? -2 plus 5 plus 3 equals 2 plus 3 plus x, correct? This 5 will come this side, right? So -2, 5 and 5 will get cancelled, plus 3 equals x. So x will be equal to 1 coulomb. Look at that, is that correct? Here 2 plus 3, 8, 8 minus 2, 6 is the next charge. Here 3 plus 6, correct. So this is the conservation of energy, 1 coulomb left. Total charge of the isolated system remains. Okay, next is quantization of charge. So quantization of charge is the principle that a charge can exist on a body only in integer multiple of basic elementary charge. That is smallest charge that can exist is charge of an electron, right, or proton. That is the smallest possible charge. All charge system of a body can exist only in integer multiple of charge. That means that is quantized, that value is quantized, that is value is fixed, okay? So that elementary charge, we can't divide that charge. That is, what is the charge of an electron? E is equal to 1.6 into 10 raised to minus 19 coulomb, okay? This is the smallest possible. Beyond that, we cannot go. Okay, you cannot transfer 1.5 E or 0.5 E. You cannot divide the elementary charge. So elementary charge, you can exist only in integral. It will exist like 2E, minus 2E, 3E, minus 3E, like that only. Okay, so we can say that the charge on a body, net charge on a body, Q is equal to plus or minus N into charge of E, correct? This is not this equation. So N is an integer multiple, like 1, 2, 3, 4, not 0.5, 0.6, like that. Okay? So this is the equation. So how can you write that? It's a statement. So this is the definition. What is quantization? You have to write like this. Charge quantization is the principle that the charge of any body exists only in integer multiple of the elementary charge. Elementary charge means E, right? So charge of a body Q can be represented plus or minus N into E, where N is an integer multiple. So this is all about quantization of charge. This is the question. 10 raised to 12 alpha particles are falling on a sphere per second. What is the time required to charge the sphere by 2 microcoulomb? So let T be the time required. To charge, right, the sphere by 2 microcoulomb. This is the time required to charge the, let T, we don't know, we have to find out that. So let T be the charge required, the time required to charge the sphere by 2 microcoulomb. So what we have to do is 10 raised to 12. What is alpha particle? Alpha particle is nucleus of helium. Nucleus of helium is proton plus 2E. So into 2E. This much charge is falling per second. Per second this much charge is going. If you multiply it with the T, total time, right? That charge should be equal to 2 into microcoulomb, right? That is correct. Charge into time, right? So this is the required charge, we know that. But we don't know the charge time required. So we put it as T and solve for T. T is equal to 2 into 10 raised to minus 6 microcoulomb is 10 raised to minus 6 divided by 10 raised to 12 into 2 into what is E? 1.6 into 10 raised to minus 90, correct? Minus 90. So this will be equal to 2 into 1.6, you can say 2 into 1.5 is 3, right? So you can write it as 2 by 3 into 10 raised to minus 6 into 10 raised to minus 12 into 10 raised to 19, correct? 10 power 19. So 19 plus this is 18, right? So 2 by 3 into 10, 16, 18, 19, 10. So what is 2 by 3? It is 0.66, right? Into 10. So what will be the value? T is equal to 6.6 seconds. This is the answer. So this is our second question. A conductor has given a charge minus 3 into 10 raised to minus 7 coulomb. Find the mass increase of the conductor and number of electrons added to the conductor. These two things you have to find out. Find the mass increase in the conductor. When a charge is given, that is electrons are transferred, minus 3 into 10 raised to minus 7. So some electrons are transferred. So definitely mass will increase because the electrons is having a mass. So this is electron is added to the conductor and the mass increase. So you have to find out two things: mass increase and the number of electrons transferred during this charging process. So you can pause the video and you can do the calculation by your own, and finally you can check the answer with this. Okay. Now I'll do this. So what is given is Q is charge is given is given right 3 into 10 raised to minus 7 coulomb. What is this charge? Q is equal to number of electrons into charge of NE, right? Q is equal to plus or minus NE. Here it is minus 3 into 10 raised to minus 7, right? So N is the number of electrons is equal to divided by the charge minus 3 into 10 raised to minus 7 divided by minus 1.6 into 10 raised to minus 19, right? This will be equal to 2 into 3 divided by 1.6 approximately 2, okay? 2 into 10 raised to minus 7 into 10 raised to 19. When this 10 raised to minus 19 comes on the numerator, it will change its sign, right? 90. So what you have to do? 10 raised to minus 7 into 10 raised to 19. So you will add this thing. So you will get 2 into 10 raised to 12 electrons, right? Electrons are transferred. 2 into 10 raised to 12 electrons are transferred during this charging process. Now we have to find the number of increase in mass, right? So if you know the mass of one electron, mass of electron is equal to 9.1 into 10 raised to minus 31 kg, right? This is mass of one electron. Such 2 into 10 raised to 12 electrons are transferred. So excess mass is equal to mass of one electron into 1.9 into 10 raised to minus 31 into number of electrons, 2 into 10 raised to 12. That will be equal to 2 times, so it will be 18.2 into 10, 2 into 9.1, 18.2, right? Into 10 raised to minus 31 into 10 raised to 12. This will be equal to 18. So you can write it as 1.82 into 10 raised to minus 19 kg is the weight excess mass given to the conductor. Clear? You can note this. So with this numerical we conclude the first video of electric charge and fields. In the next part of the chapter we will discuss about electric field. Okay, until then, see you.